Okay, this screencast, I want to go through a method of factorising, a method of factorising by completing the square. Right, so before we do so, I need to just recap a couple of things. And that is a couple of things. All right, so if we're asked to factorise a quadratic, so and it's a trinomial, so let's have a look at, say, x squared plus 4x, let's say minus 12. So you've been going, right, yeah, good, and we did some revision on this in class earlier today. Multiplies to this thing here, minus 12, adds to this number here, which is 4, two numbers that do that job. I reckon 6 and 2, 6 and minus 2 do it. And so I just go in here and say, righto, well, that's equal to x plus 6, x minus 2, and my work is done. Fantastic. What if, however, we can't find those two numbers? And that's where factorising by completing the square is going to help. But before we go into that, what is a perfect square, and how does it look? So, firstly, I want us to have a look at expanding a couple of perfect squares and just seeing if we can pick up a pattern here. So if we look at x plus 2 all squared, expansion of that. Now we need to be careful that we don't miss out that middle term, don't we? So writing it in expanded form like that is helpful. And what we end up doing is, if we look at FOIL now, right, I don't want to rush, but I also don't want to labour points that you guys are understanding, is that we go x squared plus 2x plus 2x. So we end up with this double, it always works out to be double that. So if whatever that is, 2x, you're going to get the same there, 2x. So if you can just think of that, just hold that in the back of your mind, doubling what in effect is the product of those two terms there. 2x and 2x get you 4x. So what we end up with is x squared plus 4x plus 4. Okay, so that's expanding a perfect square. And if we have a look at another example and start to look at some of the similarities, right, I'm not going to go through this time. I'm just going to look at what happens here when I expand a perfect square. Is I get the square of the x, right, the square of that term there. I get twice the product of the two. So when I say product, multiply the two together, 2x and double it, 4x. Always going to be the case, because that and that have got the same. It's the same calculation. So for this one, minus 3 times x, double that, minus 6x, square the minus 3 plus 9. So that is the expansion of that. Okay, so let's just do one more, say x plus 5 squared, and that is the square of x. Now take 5x and double it, so 5 times x, 5x, and double it. That's going to be that term there. 5, now square the 5, 25. Okay, so what I want you to look at is now the relationship between this number and this number in each of these cases. Okay, the relationship between those numbers. And what I want us to establish here is, right, in each of these cases, if I take this number here, the 4, so that's the number, that's the coefficient of x, the number in front of the x. So what I'm looking at now is identifying from a quadratic trinomial what a perfect square looks like. And this is the feature that we're going to be looking for. So if you take the 4 and you divide it by 2, you halve it. Right? So in this case, you get 2. 2 is your result. Now if you square that, you should get that there. So half of that, 2, square it, you should get that. Let's just check that works here. Halve that, minus 3. Now square minus 3. You get 9, don't you? Squaring minus 3. So minus 3 times minus 3, 9. Let's just check here with the 10. Halve it, 5. Square 5, 25. Right. So what we picked up here is that in a perfect square, what does a perfect square look like? This number will be, easier to say, maybe this number is the square of half that number. This number is the square of half that number. So if I put another example down here, x squared plus 8x, what has to go on the end here to make a perfect square? This number, whatever I put in here, has to be the square of half that number. So halve this,
4, square it, 16 goes in there. Okay, what goes in this place on the end here? Now, it's always going to be plus because you square anything. It's got to be plus. So this is the square of half this. Half that minus 1, square it, 1. Okay, so this is how we complete the square. This is how we this is how we find out a trinomial, or we manufacture a trinomial that is a perfect square. Okay, so that's the first thing I wanted to go through with you. The second thing is I wanted to go through with you just to recap what the I think we call the difference of perfect squares. Difference of perfect squares. So the difference of perfect squares was, right, factorize x squared minus 25. They're both squared terms, x squared minus 5 squared, and it factorized to, remember, x plus 5, x minus 5. So if you've got two terms, a squared minus 16, this is the two, it factorizes to the two things that are being squared, in this case a and 4, so you plant those in those spots, and then you just put a plus minus in those spots there. So hopefully you remember that. That's difference of perfect squares. So between, right, for what the 6 minutes I've taken up so far will hopefully set us up now so that we can factorize by completing the square. So what we're going to do here is have a look at an example, right? So let's have a look at an example here is factorize x squared minus 8x minus 3. Okay, factorize x squared minus 8x minus 3. So what we do is we go through the process here. I'm looking for two numbers that multiply to minus 3 and add to minus 8. We quickly establish that to multiply to minus 3, they've got to be 3 and 1. I'm never going to get minus 8 out of that, so I'm messed. I'm not going to be able to factorize using that method. So I'm going to use the completing the square method. Let me show you how that works. So what I'm going to do is I'm going to rewrite this. X squared minus 8x, they're going to hold, but I want to put another number here so that I've got a perfect square. So I'm going to write in here the number that makes it a perfect square. So I've got to halve the minus 8, minus 4, square it, 16. So I'm going to put 16 in there. Right, but already that's now my perfect square. I'm going to bracket it because that is a perfect square. I know that that's going to factorize to x minus 4 all squared. But now what I've done is I added 16 in here, and I've got to subtract that 16. Right, so I negate that move there because I've just bunged a plus 16 in there. I've now got to take it off, and I've got to put in the minus 3 that was there originally. Right, that's a bit confusing, isn't it? Right, but I've just rewritten this. I've forgotten about the minus 3. I've tagged him off on the end here, and I've just gone, no, I'm going to make a perfect square. I'm going to write in the square of half that, which is 16, but then I'm going to take it away again because otherwise I've got a different value. So this in blue is the same as this in red. Okay, but the beauty of it is that this is now a perfect square. What I forgot to mention up here was that when you are factorizing a trinomial that you know is a perfect square, then the factors are, in this case, for the 10x plus 25, it's whatever half this number is. So it'll be x plus 5 in this case, x minus 3 in this case, all squared, x plus 2 in this case, all squared. Just half of that number, half of the coefficient of x goes with the x in there as a perfect square. Alright, so in this case, half of that number, x minus 4, that's all squared. That's a perfect square. What have I got over here? Minus 19. So it's minus 16 minus 3 is minus 19. Now I'm going to bring in what we talked about here and learned about last term, difference of perfect squares, to factorize this now. X minus 4 squared. Alright, I've now got the difference of two squares, where 19 is the square root of 19 squared. So I can now write this as, my two squares are x minus 4 and square root 19, x minus 4 be square root 19, and then I just put in plus and minus, and I factorized.
Right? How hard was that? It's pretty tricky. I concede that. We're going to need to talk about this a little bit more in class, but hopefully you've got a better understanding than you did 10 minutes ago. Okay, I'll see you tomorrow.